Let's look at episode 16 of Prime Puzzles. 7 players A, B, C, D, E, F, and G participated in a chess tournament in which each player played exactly once against each of the other 6 players. So there are a total of 21 matches. The tournament started on Monday and ended on Wednesday. 3 days. An equal number of matches was played on all 3 days. So 7 matches per day. Some of the observations made on each day are given below. Then we have these observations. Prior to getting into that, we should make a table. So we have A, B, C, D, E, F, and G. We also have A, B, C, D, E, F, and G. Let me draw lines. Now, all the matches that are supposed to take place, none of these pairings can take place. F cannot play against F, G cannot play against G. So this I have to cross out. On Monday, F lost to C, D, E, and G. F lost to C, D, E, and G. And F lost to C, D, E, and G. This is all happening on day 1. This is all happening on day 1. Only one player who was not C won more than one match on Monday. I can't record this right now, so I will leave it for later. But so far on Monday, I have information for 4 matches out of 7 that are supposed to take place that day. On Tuesday, B won against C, D, and E. B won against C, D, and E. B won against C, D, and E. And this is all on Tuesday. Okay, E lost to A and C. E lost to A and C. This is on Tuesday. E lost to A and C on Tuesday. G won exactly 2 matches on Tuesday. Again, I can't really record this information right now, but I know on Tuesday I have information of 5 matches. I have information for 5 matches on Tuesday. Let's look at Wednesday. G lost to B. G lost to B, but won against A and C. So B, G, G. This is on Wednesday. Lost to B, won against A, won against C. This is on Wednesday. D won against C and E. So D, 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 D. This is all happening on Wednesday. F lost to A and B. So A won here on day 3. A won here on day 3. B won here on day 3. B won here on day 3. For Wednesday, I already have information for 7 matches now. For Wednesday, I already have information for 7 matches now. So this is fine. Last piece of information is it is known that none of the matches ended in a draw or a tie, and each player won a distinct number of matches in the tournament. If each player won a distinct number of matches in the tournament, the only way it can go down is if somebody won 6 matches, somebody won 5 matches, somebody won how many matches? 4, 3, 2, 1, and 0. This will be the count of matches won by different participants. Okay, let's go ahead and try to use these three pieces of information. The second one from Monday, the third one from Tuesday, and this last piece of information. Out of these, look at this piece of information. G won exactly 2 matches on Tuesday. But so far, we have no match of G happening on Tuesday at all, which would mean the 2 matches that G won on Tuesday would be against D and against E. G winning here, G winning here. We have all this already. Now G has won how many matches? 1, 2, 3, 4, 5. G has won 5 matches. How many matches is F winning? 0. How many matches is E winning? 1. These three are already out. Now somebody out of A, B, C, D is supposed to win all 6 matches. Somebody out of A, B, C, D is supposed to win all 6 matches. Can A be that person? No, he's already lost to G. Can B be that person? Yes. Can C be that person? No, he has lost 3 matches so far. Can D be that person? No, he has lost 2 matches so far. Therefore, the person who won 6 matches has to be B. And B, pay attention. For Tuesday, we already have 7 matches now. After incorporating information for G, we have 7 matches for Tuesday. So Tuesday is taken care of, Wednesday is taken care of. The only matches that we are going to assign now are going to be on Monday. And B's match on Monday against A resulted in B winning. This is also taken care of. Okay. So now next thing, only one player who was not C, won more than one match on Monday. On Monday, C is not winning more than one match. So the match between A and C, which will happen on Monday, will be won by A. A will definitely win it. But the match, now see, C has won how many matches? 2 matches, already taken care of. C is winning 6 matches, already taken care of. A has currently won 3 matches. D has currently won 3 matches. Now the match between A and D, either of them can win. Either A will have 3 wins or 4 wins. Correspondingly, either D will have 4 wins or 3 wins. We don't really know what happens in the match between D and A, but 3 wins or 4 wins, this is uniquely identified. Let's get to individual questions. Who won the highest number of matches in the tournament? Highest number of matches in the tournament was won by B, so option D. Who won more than one match on Monday? More than one match on Monday was won by either A or D. It was either A. If A wins here, it would be on a Monday and he would win 2 matches on a Monday. Or if D wins here, D would have won against A, D would have won against F, D would have won 2 matches on a Monday. We cannot really be certain. Therefore, the answer has to be option D, cannot be determined. Popat, an avid chess buff, watched all the matches on tournament except the ones that took place on Monday. How many times did he see either B or D winning a match? Basically, what they're asking is how many matches did B and D win on Tuesday and Wednesday combined? So let's look at B. 1, 2, 3, 4, 5 wins. And for D, this match. I don't know the outcome for it, but this is happening on Monday, so I don't really care. Here it is going to be D1 and 2. 2 matches of D on Wednesday 1 and 3 matches of B on Tuesday 1 and 2 matches of B on Wednesday 1. So total matches 7 he will see B or D winning. So option D. Last question. On how many days during the tournament did at least one player win more than 2 matches? More than 2 matches. Okay. Now see, on Monday, A is winning either 2 matches or D is winning 2 matches, but nobody is winning 3 matches. On Monday, nobody is winning more than 2 matches. This is guaranteed. On Tuesday, can I see somebody winning more than 2 matches? Yes. D is winning on Tuesday. B is winning more than 2 matches. Against C, against D, against E, he won more than 2 matches. Let's see on Wednesday if somebody is winning 3 matches. No, 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 No. And no. On Wednesday also, nobody has won more than 2 matches, 3 or more matches. On Wednesday, nobody has won more than 2 matches. And Wednesday, nobody has won 3 or more matches. So the only day during the tournament that somebody won more than 2 matches was Tuesday. Answer to this question should be option B. Let's get to the next set. 4 security officers, Andrew, Joseph, Parry, and Lucas, were responsible for guarding the Kohinoor diamond during one-day exhibition held recently. The exhibition started at 10 a.m. and finished at 5 p.m. The officers operated in 1-hour shifts, and at least one officer guarded the diamond in each of the 7 shifts. None of the officers operated in 2 consecutive shifts, and none of them joined or left a shift midway. Okay, so there are 7 shifts, no? Let's record 10, 11, 12, 1, 2, 3, and 4. These are the 7 shifts that are available. First information is Andrew operated in exactly 4 shifts. And we also know that none of the officers operated in 2 consecutive shifts. The only way this goes down is if Andrew operated here and here and here and here. Andrew worked in these 4 shifts. 2 officers were operating at 12:40 p.m. One of the 2 was Joseph. So if 2 officers were operating at 12:40 p.m., can I say it must have been the slot 12 to 1? And one of the 2 was Joseph. The other one I already know is Andrew. The other one has to be Joseph. So this slot is entirely full information is available because there were only 2 officers there. Andrew and Joseph are done. Parry operated in exactly 3 shifts and he was operating at 1:20 p.m. If he was operating at 1:20 p.m., Parry must be working at this time slot. Okay. Lucas operated in exactly 2 shifts and he operated alone in both of them. If Lucas operated in exactly 2 shifts and he operated alone in both of them, the only slots where Lucas can work is 11 a.m. and 3 p.m. So this is Lucas. And we have got all the information that we can potentially get about this here. We have got all the information that we can potentially get about 3 p.m. slot. Each of the 4 officers operated in at least 2 shifts. So everybody has to work for at least 2 shifts. Joseph and Parry never operated together in any of the shifts. Joseph and Parry never operated in any of the shifts. Okay. So the only piece of information that I have to take care of is this. Parry operated in exactly 3 shifts and Joseph and Parry never operated together in any of the shifts. Parry needs 3 shifts. He cannot be at 11, he cannot be at 12, he cannot be at 2. He cannot be at 2 because it would be 2 consecutive shifts. So Parry has to work here. And Parry has to work here. Now see, Andrew operated in 4 shifts is done. Parry and Lucas operated in 2 shifts is done. And wherever Parry is coming, Joseph cannot come. So the 10 o'clock slot is already fixed. The 4 o'clock slot is already fixed. We need Joseph somewhere. We need Joseph in at least 2 shifts because each of the officers operated in at least 2 shifts. We have Joseph once. The other slot where Joseph can come is at 2 p.m. And as soon as Joseph comes, Parry cannot come. So this is also fixed. This is also fixed. And I have all the 7 slots. Who is working at what time? We know. First question, in how many shifts did Joseph operate? Joseph operated in 2 shifts. So answer to the first question is 2. How many shifts were there in which just one of the 4 officers operated? The shift at 11 a.m., the shift at 1 p.m. and the shift at 3 p.m. So there were 3 shifts in total in which just one of the 4 officers operated. At what time did Joseph leave for his home if it is known that he left immediately after completing his last shift on the day of the exhibition? Joseph was working the 2 p.m. shift. So 2 p.m. to 3 p.m. he worked and then he left at 3 p.m. Answer should be option A. Last question. What is the absolute difference between the number of shifts in which Andrew operated and the number of shifts in which Joseph operated? Andrew operated in 4 shifts, Joseph operated in 2 shifts. So the absolute difference between them is 2. And that is the entirety of this set. Hopefully you learned something from these 2 sets. That will be all. Okay, bye.